Hello, and today we're going to talk about radicals and rational exponents. So here's a lovely cartoon where it just kind of depicts all the math and all the things that we're going to be dealing with. We're not going to be dealing with just square roots anymore, guys. We're going to be dealing with things a little bit different. We're going to be dealing things that have powers higher than 2. So we're not going to be taking square roots. We'll be taking cube roots and fourth roots and fifth roots and all that fun things. So we're going to call this, and it's kind of good for you to have this doodle in here. Don't worry about the n is cannot be 0 because there's no n there. But this number right here is not, we're not going to be calling it the index, we're going to be calling it the root. When we were doing this before, we talked about the square root or cube root. We're going to be talking about root 3, root 2, and things like that, just to kind of speed up our dialogue. So let's talk about a few things. Anytime we're going to be simplifying fractional exponents, we will rewrite the exponent as a radical raised to a power. And make sure you have this written down. I know I didn't include the beautiful red text to write it down, but write it down. Okay? The denominator of the fractional exponent is the root, and the numerator is the power. So you're going to see something like x to the 2/3, right? Our power there, so say I had something like x to the 2/3. 2 would be our power, and our root would be 3. We'd be able to rewrite this as the cube root of x squared. Not that much of a different change. We always need to know that the denominator of the fraction is always the root, and the numerator is the power. Whatever either our number is or our variable, that's how we're going to simplify these. And here's also a kind of example of what we're talking about. The radical form of the x squared, or the fifth root of x squared, would be x to the 2/5. So anytime you have a variable and just even a number, the nth root of it, you can rewrite that as a to the 1/n. If it were in the denominator, because it's a negative exponent there, right, we would be able to rewrite this by bringing it up top as a negative root of a. Then we're going to call that a to the negative 1/n. And that's what we're going to do today. We're going to be dealing with these in terms of trying to get it from a fractional to a exponential form. So let's look at an example. Write the following as a fractional exponent. So if I had the cube root of 27 squared, I can rewrite that as 27 to the 2/3. I can actually go further here because we know that the cube root of 27 is just 3, right? 3 times 3 is 9, times 3 would be 27. So now this would become 3 squared, which actually simplifies down to 9. So that gets a little bit complicated here, but that's how we can do it. And that's not going to work in every case, right? If I had something like the cube root of 6 squared, it's not going to work. If I had something like the fourth root of y to the 6th, well, I can rewrite that as y to the 6/4, and we know we can always simplify down those fractions to the most simplified form, which would be y to the 3/2. So I want you to pause the video here and try these ones really quickly, okay? Alright, so the first one, we would have that as 2 to the 1/3. The second one, it would be m to the 3/4. The third one would be 2 to the 6/5. It's a weird looking 6/5. And the last one would be the quantity, and make sure you put the quantity here, guys. So put that in parentheses, 3k to the 1/5. And that's all we can do, right? We can't simplify it just like we did with the other one. We can't simplify it like we did with this one because that was a lucky case where we had we knew the cube root of 27. Okay, so let's just try a little bit more. Now we're going to write as a radical and simplify. So if we can, we're going to simplify it down even further. If I started with 7 to the 1/2, I could rewrite that. I could write that in the radical form as the square root of 7. If I had 4 to the 2/3, I can write that as the cube root of 4 squared, or the cube root of 16. And lastly, if I had 6x, the quantity, to the 4 thirds, that means the cube root of the quantity 6x to the fourth. Okay, so what I would like you to do is to try these out real quick. Try to write it from exponential form to radical form. Go ahead. Pause the video here and I'll show you what they all are. So here I would have this as the cube root of 36 because that's the cube root of 6 squared, and 6 squared is just 36. This next one would be the fifth root of m to the 6th. Next we have, since that's a negative power, right, I need to put that in the denominator. So it would be 1 over, that'd be fourth root of the quantity 5m to the 5th. And again, that's not really our simplified form, so don't worry about that. We'll talk about that in class. And then lastly, we could have the square root of the quantity 10n cubed. Okay, and just that last one, we'd be able to rewrite that as, wait for it, the cube root, because 3 is in the denominator there, the cube root of negative 8x to the third, and that all raised to the fourth power. Now, we can simplify that down even further, though. And the reason we are allowed to have a negative in the radical here, because I know we've talked about it and we said, hey, if we're taking a radical, like if we're taking a square root, we can't have a negative. But if we are taking a cube root, we can, because anytime you have an odd power, if you're taking an odd root, that means you're allowed to have an odd amount of negatives. You can also have a positive amount, right? But if I have an odd amount of negatives, then so for example, if I had negative 2 cubed, then that would be negative 2 times negative 2 times negative 2, or negative 8. The same way that would work is if I were going to take negative 8 to the 1/3, we know that that's just going to be the cube root of negative 8, or just negative 2. So it works both ways, and that works only if we're dealing with odd roots. So 3, 5, 7, and so on. We're not going to be taking a first root or anything like that. But the one thing I'm saying is we can simplify that down even further if we want to by raising negative 8, the quantity negative 8, to the fourth power by taking, you can either put that in your calculator or however you want to do it, and you would get that as the cube root of 4096 x to the 12th. Now, this is where it gets a little bit complicated, and we could have even done this in the beginning step. As I just said, we kind of know the cube root of our powers to begin with, right? Before I'm even taking that raising it to the fourth power, I can say, well, I know the cube root. If I were just going to take the cube root of negative x 8 to the third, before I even raise that whole thing to the fourth power, I know the cube root of negative 8 is negative 2. And just like how I was doing before with square roots, I'm going to do the same thing with my x's here. But instead of dividing by 2 like I did with square roots, I just need to divide the exponent by 3. So this would be x to the 3 over 3, or just simply x to the first. And then I can take the whole thing and raise that to the fourth power. So negative 2 to the fourth power would be 16x to the fourth. So that is as far as it can be simplified down. And I know a lot of you may have stopped right after here, but you can keep going down all the way to there. Okay, let's look at a few more of those. So let's try this and try to make sure you have this written down as well. First, what we're going to be doing is we're going to break this up into what we're really looking at. And really, we can break it up just like how we did every other one. When we had square roots, we were dividing our exponents by 2, and since here we're taking the cube root, we need to divide our exponents by 3. So we're going to try to see if we can get clusters of 3 here. So we're, instead of trying to find even numbers, we're just trying to find groups of 3. The first thing I realize is the cube root of 8 is just 2. So if I'm taking the cube root of 8, I know that's just 2. Here, if I were to try to break down x to the 5th, I kind of want to do that because I'm doing the cube root. I kind of want to break that down to the cube root of x to the third, and I still have that x squared left over, right? Because x to the fifth becomes x to the third times x squared. This doesn't run into, I don't have any problems with y to the sixth because it's already a multiple of 3, right? That power is, 6 is a multiple of 3. Next, with the z, I need to break that down to z to the ninth times the cube root of z squared. So from here, I can just simplify, right? The cube root of x to the third is just x. The cube root of y to the sixth is y squared. So I have 2xy squared. And the cube root of z to the ninth is z to the third. From there, I'm still left with the cube root of x squared z squared. And that's all I can do. That's the farthest I can simplify that down, because I can't divide the x or the z by 3. And let's show you a little bit different of a method here. So for example, if I want to simplify this one, I could say, first of all, I kind of need to know my cube roots here, and we're not going to get too crazy with it, but we should be able to know that 8 goes into this, and 8's kind of one of those really nice cube root numbers. So I break this down to the cube root of 8 and the cube root of 3. Now what I'm going to do is I'm going to take my a's, and instead of, I'm kind of going to write it back into that exponential form. So I'm going to take this as, since my power is 3, that's a cubed, and my root is 3, so 3 goes in the denominator. Let's do it with a b as well. So the b, our power is 4, so the 4 goes in the numerator, and I have 3 in my denominator. And lastly with c, that's c to the seventh, again over 3. And the reason we might want to do this is because here I know, well, the cube root of 8 is just 2. But I can't really do anything with that 3. I know that's going to still be left underneath the radical. So now I can divide my a, and a to the 3 over 3, well, that's just a to the first. Right, that b becomes b. If I want to try to put it almost as a mixed number, which is kind of where it gets weird, this would be b to the 1 1/3. That c, we know it's going to go in twice, so that would be c to the 2 1/3. Now the 1 and the 2 there, the 1 and the 2 are going to be kind of my whole powers left over. But b to the 1/3 and c to the 1/3, that means I still need to break this down. So I can break this down to b times b to the 1/3, and this is c squared times c to the 1/3. And anytime I have a fractional power, I need to rewrite that underneath my exponent. So this would be 2a, and then I have that b left over, that c squared left over, and then I have the cube root of bc. And that's, 3bc, right? I have that 3 left over from the 24. And that's all I could do. And I understand this is kind of a bit of a confusing topic here, so make sure you any questions you have, make sure you bring them to class. So let's have you try some problems now. You can use either the first method I used or the second. So pause the video here and try out these two problems. With this first one, I know the cube root, again we see that 8 there, so I know I'm going to have, I can break this down to 8 and 2, and the cube root of 8 is just 2, but I can't do anything with that cube root of 2 still. That just has to stay underneath the radical. Then I can take this as x to the 4 over 3, y to the 6 over 3, and z to the 5 over 3. That means I'm going to have x to the 1 1/3, y squared, and z to the 1 2/3. And I still have that 2 cube roots of 2. So obviously I want to break this down and make that as x to the first times x to the 1/3. Still have that y squared, but the z becomes z to the first times z to the 2/3. And because I have that 2/3 there, I don't really want to have that, so I need to rewrite this as what's underneath that cube root. So this would be 2, and then x to the first, y squared, z to the first. Then underneath the radical, underneath that cube root, I have that original 2 that I couldn't get rid of. That x to the first power because it has that power of 1, and z to the second because it has that power of 2. So my final answer would be 2xy squared z cube roots of 2xz squared. Which sounds ridiculous to say, I'm aware, but let's try the other one. So this next one, all I have to do is I'm now taking the fourth root, which means I have to divide by 4. And I use 16 for a reason because 16 is one of those lovely fourth roots. It's just 2 times 2 times 2 times 2. So the fourth root of 16 is just simple.